Hello and welcome. My name is Marlo Stevens. I'm the Business Development Director of the Facility Robotics Division here at Autonomous Solutions Incorporated. On behalf of everyone here at ASI, we welcome and thank you for joining us for the live broadcast of our Smart Yard Shifting solution. We are also recording this at the ASI facilities through YouTube Live to allow for others to watch and review later. In light of the current economic and social situation, it's unfortunate that we do not have the opportunity to meet with you face-to-face and to allow you to see this in person, but we hope you'll find this virtual demonstration as interesting, informative, and as exciting as we do. We feel that Aristotle said it best when he quoted that the whole is greater than the sum of its parts. We feel this aptly applies to the group of companies we have here today. At ASI, we are world-leading automation experts with 20 years of autonomous experience, offering a state-of-the-art software solution and specializing in worldwide OEM agnostic deployments. We are partnering with Phantom Auto, who provides reliable, low-latency communications, teleop, and remote monitoring. Our yard truck today is being provided by Terberg, who have been in the business for over 150 years, offering proven reliability in the autonomous-ready auto tug. We are also partnered with FANUC, the world leader in robotic arms, vision systems, and in accelerated automated solutions. Our demonstration today is being done to simulate what could be a typical distribution center loop for a yard truck. We will use this flow diagram to assist in visualizing the sequence. First, we will start with the YMS, or Yard Management System, triggering a dispatch request to Mobius for a vehicle. Mobius can then be used to select a yard truck and navigate it autonomously from its staging area to a loading location where a trailer is waiting to be picked up. Once there, autonomous operations will be transitioned over to a teleoperator who will back the truck up to and connect the trailer. Control of the truck and trailer will then be turned back over to the command and control system, where Mobius will autonomously transport the yard truck and trailer to a designated drop-off location. After arriving at its destination, Mobius will notify the teleoperator that the trailer is ready to be backed up into a delivery bay for unloading. We will briefly address the minimum viable product feature set that we targeted for this demo. Hopefully that will help clarify the scope of what has been done. We also want to go over some of the operational metrics and to briefly share our roadmap of future features. For our MVP, we've included full A to B autonomy for hands-free operation and navigation of the truck and trailer. We also look to try to achieve full autonomous airline coupling and decoupling of the trailer's parking brakes. We have implemented this MVP with no modifications to the trailer. We also look to use and leverage multi-vehicle command and control, obstacle detection and avoidance, and a traffic management system. All of this is made possible through Mobius. We are targeting operational speeds of 15 miles an hour, and we look to address the complex maneuvers and edge case handling as well. Our target operational metrics include a 20 to 30 second connection with the trailer. This is done via teleop. 6 to 8 seconds for the autonomous glad hand connections, approximately 45 seconds to back into a dock, and then we are targeting a 1 to 5 operator to vehicle ratio. Additionally, some of the items on our roadmap that we are looking to address in the near future include swivel glad hands, swing doors, wheel chocks, and electric hookup. To help and better clarify a couple of the different components in the systems that we'll see today, we have two main areas of focus. The left-hand side of the screen is the command and control solution Mobius. This provides the operational map and integration capability with the YMS to ensure queue priorities and workflow. We also have Phantom Auto's teleop setup and the communication stack, which enables the onboard cameras and remote operations. On the right-hand side of the screen, we have the Terberg drive-by-wire auto tug, which is serving as our yard truck and will be providing trailer pickup and delivery for today's demo. On board, we leverage the FANUC arm and vision system for the autonomous coupling and decoupling of the glad hands. Due to the current restrictions on travel, the venue for today's demonstration is going to take place here at the ASI facilities on one of its durability test tracks, which we call the Figure 8. We will simulate three principal areas of a distribution center for the purposes of our demo. First will be an inbound staging area, the second a loading and unloading zone, and a third an empty or waiting area. We've placed our pickup and drop-off locations on the same track to reduce travel time. We do not have testing docks here at our facility at ASI, so our teleoperator will be backing into a parking location. However, the concept and the implementation during teleop would virtually be the same at a distribution center. This slide shows the remote teleoperator's screen setup. It consists of 5 different screens for this demonstration. Starting in the top left, we have Mobius, our autonomous command and control software solution. To the right of that, we have a screen providing a simulation of a YMS that would typically be found at a distribution center that would be leveraged to ensure and oversee job queues. The lower 3 screens are a combination of the 6 onboard cameras, 3 forward-facing and 3 rear-facing. Different configurations of these screens enable teleop and offer a wide variety of angles to ensure the safety operation of the vehicle. During our demonstration, we're going to have 4 different video screens that we'll be sharing and switching between. The first screen is showing our command and control software, Mobius. The second is a broadcast from inside the control room here at ASI, showing the teleoperator as he monitors a number of different camera feeds that are streaming live videos from the yard truck. We also have an overview of the track cam, which shows a bird's eye view of the venue where we'll be doing our demonstration today. The last window is a screen showing yard truck footage from different angles, as well as a live view of the arm that we'll use to show what's happening at various points during the demo. So our demonstration today will begin with a simulated YMS job being passed into Mobius. Mobius will then subsequently take autonomous control of the yard truck, which is currently parked in an empty staging area on the far side of our track. This operation is activated by a simple click of the play button. We see that the selected path of navigation is highlighted in Mobius in yellow. Mobius then maneuvers the yard truck from its waiting location, in our case the empty staging area, to the loading zone represented in the nearest intersection of our figure 8 track. Here is a view from our track cam showing the truck on the right hand side of the screen as it's responding to and anonymously moving into its new designated location. Here's an overview of the AutoTug as it's moving along the path. Mobius navigates the yard truck to the previously defined location, the loading zone on the map. It will then halt the truck. Autonomous functionality is now suspended and handed over to our teleoperator in the control room for manual operations of the truck. The operator will back the yard truck into position with the assistance of the numerous onboard cameras until the connection with the trailer is made. The handoff between Mobius and the operator is fairly seamless and can be formed from an on-site control room or a control room several thousand miles away. We leverage Phantom technology to do this. Once the mechanical and the electronic connections between the yard truck and the trailer's kingpin are made, this will indicate to the operator that the coupling with the trailer is now ready. The operator will issue a command through Mobius to activate the arm to establish the coupling of the glad hands and to release the air brakes on the trailer. The arm will perform one to several scans of the trailer to locate the position of the arm and enable the connection. Once the location of the trailer's glad hand is established, the arm will couple the glad hands, subsequently retracting to a safe location for travel. The system is then pressurized to release the trailer's parking brakes. The boom is then lifted so the trailer is ready to be moved. The control room operator will now move the truck and trailer out of the manual operation zone. So at this point, control is handed back over to Mobius for autonomous operation. In a normal distribution center setting, Mobius could be instructed to navigate the truck to a loading or unloading zone several hundred yards away or many miles away, depending on the size of the distribution center. Here we can see the newly selected path in Mobius, showing again in yellow. At this point, the operator in the control room is left to manage other tasks and can simply observe a screen from the truck as it navigates through its path to the drop-off point. Because the truck is being driven autonomously, this frees up the hands-on obligations of the operator, enabling him to observe, control, and oversee the operation of numerous trucks in one or several distribution centers simultaneously. Here's a bird's eye view of our mock-up distribution center as Mobius controls the vehicle to the previously specified drop-off location. Here in Mobius, we can see that the vehicle is pulling up to the location on the map where it will hand off the autonomous navigation over to the teleoperator. The controller will be notified that the manual operations can now take place. We are now able to see that the operator has taken control of the auto tug and will be manually backing the truck and trailer into position. One advantage that this hybrid system between the autonomous solution and the teleoperation is that the ability for the human to help oversee the effective and efficient parking and safety of the trailer. And it also allows them to communicate with other systems like manual or electronic dock locks that may be at the distribution center, but which may not be available for autonomous operation at this juncture. Here we'll go ahead and watch as the operator backs the trailer up into position. Once the teleoperator has completed this action, he will stop the truck and release the air pressure from the system. The boom will be lowered and the FANUC arm will be instructed to remove the glad hand. The arms will cycle through a predefined set of seek points to get a perspective of the trailer's glad hand. This procedure is very useful to help to account for the different angles that a trailer is likely to be parked in. No one parks perfectly every time, and this fail-safe system will help to account for that. Following the retraction of the arm, control is handed back over to Mobius to enable the yard truck to be autonomously dispatched on another mission or to await further instructions depending on the need of the distribution center. One additional piece of footage we want to share with you is the range of dynamic capability that the FANUC Vision system offers to be able to adapt not only to various trailers, but to a wide variety of glad hand positions. This single video take we filmed in our shop shows the various positions and angles the FANUC arm and Mobius are capable of adapting to in order to find and couple glad hands. This concludes our demo. Thank you for your time.